structure that helps us to store data in contiguous locations in memory. That is, when you store the data in the RAM, they will be in contiguous locations so that it is easier for us to travel from one data to the other. An example array is given here. In this, we have 7 elements and we represent the position of each element using index or subscript. The first element is 3 and it is at location 0. The second element 19 at 1 and the last element, which is the 7th element, is at location 6. When I want to access the 0th element, I access it as a of 0 is equal to 3. When I have to access the 4th element, I give a of 3 is equal to 2. What happens when I give a of 5? It automatically goes to the 5th element, or in other words, it jumps to the 5th element without going through the previous elements. And I have called my array as A. So if I give a of 5, I directly access the 5th element and this is called as random access. The time taken for me to access the 5th element is only 1 and so the time complexity for access is big O of 1 and this is the biggest advantage of using a array. These are called as linear data structures. That is, I know that for 19 the successor is 8 and the predecessor is 3. There is absolutely no ambiguity there. The way the memory is allocated in an array is, it can either be fixed or it can be dynamic. A fixed array in Python is probably the array module and the NumPy that is generally used for mathematical calculations. And the dynamic array are the lists in an array. So we know that when we have a list, we can have mixed types, whereas when we have an array, all the elements have to be of a single data type. But arrays are generally faster for numerical tasks.